remember when we did linear functions, we were able to find equations of lines either given a point and a slope or given 2 points. Well, what we're going to do here is pretty much the same thing, only now we're going to find the equation of a parabola given a vertex and a point somewhere on that parabola. You'll notice here I went ahead and I drew a figure because I always think it's important to be able to visualize what we're doing. What we're going to do in this particular problem is we're going to find the equation of the parabola that has a vertex of 4, 5, and somewhere on that parabola is going to be the point 5, 3. Okay, somewhere on that parabola is going to be the point 5, 3. If you take a look at the points that I have here, here's my vertex 4, 5. Here's my point 5, 3. Now, since the point 5, 3 is below the vertex, I know right away that if I graph this parabola, it would open downward, right? So that means when I do find the equation of this parabola, shouldn't A be negative? Shouldn't A be negative? Because this particular vertex should be a maximum on this graph. Everybody good with that? Good there? Okay. Very easy process. If you remember when we did linear functions, we used a formula, right? Y minus y1 equals m times x minus x, or x minus x1, and we went ahead and we were going to come up with our equation, correct? We're going to do the same thing here, only this time we're going to use the formula that we've been using. Y equals a times x minus h, the quantity squared, plus k. And what we're going to do is we're just going to go ahead and plug our numbers into what we have. Now, if this is helpful, you can do this. Your vertex has to be hk. Has to be hk. That's what your vertex is when it's in this form. Your point has to be xy, right? So what's the only variable we don't have? A. We've got h, we've got k, we've got x, we've got y. So what we're looking for is we're looking for a. Is what we're looking for in this particular problem. So what I'm going to do now is I'm just going to take these numbers and plug them into this formula. Well, y is 3 equals a times x, which is 5, minus h, which is 4, the quantity squared, plus k, which is also 5. Everybody okay where the numbers go? Okay. Now we're just going to do some arithmetic in order to go and find out what a is. So I've got 3 equals 5 minus 4 is 1. 1 squared is 1. 1 times a is a plus 5. I'm going to go ahead and subtract 5, and I end up with a is equal to negative 2. A is equal to negative 2. Which it should be, right? A needs to be negative because my vertex is a maximum and this parabola opens downward. Now that's good, I found A, but I'm not finished. I need the actual equation. So we need to put it into this form. So I'd have y equals A, which is negative 2, times x minus h, which is 4, the quantity squared, plus 5. There is the equation of the parabola that has 4, 5 as its vertex, and somewhere on that parabola is the point 5, 3. And we could use this information to find everything else out that we needed. We can find out exactly where this parabola crosses the x-axis because we have the equation. We can find exactly where the y-intercept is for this particular parabola because we have the equation. But what I wanted to do is make a comparison to what we had done basically when we found equations of lines given 2 points. We can find equations of parabolas given a vertex and a point. Everybody okay with that example? Good shape there? Okay.